we're going to talk about these two words, parallel and perpendicular. And you've heard of that before in a geometry class. Look up here at my picture. Parallel means the two lines are never going to touch. They're never going to intersect. Now, you can't just judge by your eye if two lines are parallel. Remember, lines have arrows on the end. They extend on forever and ever. Eventually, they could meet. So we have a rule. The way you know lines are parallel is they're going to move the same way. And that word move is your slope. So if you look at your first line, the equation is y equals negative 2x plus 4. And that makes sense. The y-intercept's at 4, and they went down 2 to the right 1, down 2 to the right 1. And that's how they formed that line. The slope is what number? Negative 2. If you look at the other line's equation, y equals negative 2x minus 3, we know by looking at that equation the slope is negative 2, the y-intercept's negative 3. So to graph that line, they went to the y-axis to negative 3, and they still moved down 2 to the right 1, down 2 to the right 1. What was that line's slope? Good, it was negative 2. What I want you to notice is both of those equations have the same number for slope. What's their number for slope? Negative 2. If two lines' slopes are the same, that means the two lines are moving the same way. And if you move the same way at all times, you're never going to touch. That's how you tell if the lines are parallel. They would have the same number for slope. So, if I told you my line slope was 5, and you're going to be parallel to me, what's your line slope going to be? Very good. It's also going to be 5. Because if we're parallel, we're going to move the same way. We're going to have the same slope. Let's look at the next picture. This is a picture of perpendicular lines. Now, perpendicular means they're going to intersect. Intersect means touch. But they don't just touch anyway. They touch and form a 90-degree angle, a right angle. So if you look at that picture, it is obvious those two lines do intersect. And if you look, the angles formed are 90 degrees, just like when the x and y axis intersect. They make 90 degrees, the little box. Well, again, you can't let your eye be the judge. To know if those lines are really perpendicular, there's a relationship with their slopes. So look at the first equation. Y equals 4x plus 1. The y-intercept's at 1, so we went to 1 on the y-axis, and then the slope was 4. So we counted up 4 to the right 1, and that's how we drew that line. The next equation is y equals negative 1/4 x minus 3. So we went to the y-intercept of negative 3, and that slope meant to go down 1 to the right 4. And that's how we got that line. If you look closely, are the slopes the same number? Nope, they're not. If you look closely, the numbers for slope have a special relationship. One slope is 4. The other slope is negative 1/4. So there's two things going on. The first thing you'll notice is they're opposites of each other. The opposite of a positive is a negative. So two lines that are perpendicular, their slopes are always going to be opposite. But they're not just opposites, they're also reciprocals. What does reciprocal mean to do? It means to flip the fraction. So if you look, the first equation, its slope was 4. That's 4 over 1. If you flip that, do the reciprocal, the other slope is 1 over 4. So we say if lines are perpendicular, their slopes are opposite reciprocals. So let's try an example. So if you look here, we're going to go up to the board, we're going to look at this example. So let's go to the whiteboard. Okay, I'm giving you 2 points. Point A is at 2, negative 4. Point B is at negative 2, negative 16. And the direction says find the slope. So we just learned there are many ways to find slope. We could plot these points and count boxes. But here I am, I have a problem. Does my graph go up to negative 16? Go down to negative 16? No. So I can't use my graph paper for this. So the way I know I can find the slope here is to use the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. which is basically just remembering rise over run. So if you look, I'm going to label who my x and my y are. So I'm going to do my formula. I'm going to subtract my y's. I'm going to subtract my x's. So my first y is -4, and I'm going to subtract that from -16. Then I'm going to do my x's the same way. My first x is 2, and I'm going to subtract it from -2. Doing our arithmetic, 2 negatives make a positive, 2 negatives make a positive, and now look what we get. -4 plus 16 is 12. 2 plus 2 is 4. And 12 over 4 is 3. So the slope, the movement between these 2 points would be up 12 to the right 4. Or simply, up 3 to the right 1. Now, the question A says, find the slope of a line that would be parallel. So if I plotted these 2 points and I wanted a line that would be parallel to this, parallel means it would move the same way. Well, that's very simple. If you're parallel, you're going to be the same slope number. What is the slope of this line? 3. So the slope of the line parallel would also be 3. It would move the same way. On part B, it asks for the slope of the line perpendicular. Well, if you're perpendicular, you're going to want to cross, which means you're not going to move the same way. The rule is if you're perpendicular, the slopes are opposite reciprocals. So if you look, this slope is 3. If I'm going to draw a line perpendicular, my line's not going to move up 3 to the right 1. It's going to move opposite, which means it's going to be negative. And it's going to be the reciprocal of 3, which is 1/3. So a line that's drawn perpendicular would move down 1 to the right 3. It would be the opposite reciprocal of this slope. Is everybody with me on that? So that's the key. You've got to memorize that. All right, we have one more example to look for in our notes. This one I love. It says, determine if the lines are parallel, perpendicular, or neither without graphing. And here's where we like shortcuts. Let's look at the first equation. We are given in A, y equals x plus 1. We're also given y equals -x plus 1. So look, let's put the whole chapter together. If you look, these are both equations of what types of lines? Diagonal. They both have an x and a y. I could ask you to get out the graph paper and graph them and look and see if they're parallel, perpendicular, or neither. You don't need to do that work. The concept is anytime you hear the word parallel and perpendicular, there's a relationship with the slopes. So now let's use what we learned. Can you look at this equation and tell me the number for slope? Slope stands for m. M means multiplied. What's multiplied to x? 1. How do you write slope as a fraction? 1/1. Let's look at this diagonal line. Slope stands for m. M means multiplied. What's being multiplied to x? -1. How do you write that as a fraction? Put it over 1. So now look, are these the same number? No, they're not. Are they opposite reciprocals? This is positive, this is negative. That's an opposite. If we take 1/1 and flip it, we would get 1/1. These slopes are opposite reciprocals. And the rule is, if the slopes are opposite reciprocals, without drawing the picture, I know when if I draw these lines would be perpendicular. They would crisscross at 90 degrees. Now I'll prove it to you. If we go to the board and I graph this line, the y-intercept's 1. The slope is up 1 to the right 1, up 1 to the right 1. And there's that line. Okay? If I draw this line, the y-intercept's still positive 1, but the slope is down 1 to the right 1, down 1 to the right 1. If you look very closely, these lines intersect, and right there is a 90-degree angle. I don't have a problem with you drawing the picture, but you don't need to. If you want to know if the lines are parallel or perpendicular, all you got to do is look at their slopes. Let's look at the next example. Okay, I have two equations. I have y equals -2x plus 1, And then I have 2x plus y equals 5. Okay, we're always going back to the basics. If I give you an equation, what type of line it is? They both have an x and a y. They both got to be diagonal. If they're diagonal lines, they always have to be in what form? Slope-intercept. Is this in slope-intercept? Sure. Then you should see the number for slope, the number that's being multiplied. That's a -2. We always write it as a fraction. Is this equation in slope-intercept? No, this is called standard form. We got to move it around. So to get y by itself, we're going to subtract 2x, subtract 2x. Y equals, put the x first, and then that's a +5. Now do you know the number for slope? Slope is m. M means multiplied. We got a -2. Write it as a fraction over 1. Now, I don't need to draw these lines. I have enough information. If this slope means the line's moving down 2 to the right 1, and this line slope means you're moving down 2 to the right 1, they're moving the same way. Think about it. You had a point here and a point here. If I move them both down 1, 2, and to the right 1, they will not touch. If you move the same way, if your slope's the same, that guarantees your lines are going to be parallel. So that's all I need. Knowing those slopes will tell me if I draw these two lines, they'll be parallel. They'll never touch. All right, we got one more example. So our last example, we have two equations. We have x plus y equals 5, and we have 2x plus y equals 5. What types of lines are they? It has an x and a y, it's diagonal. Has an x and a y, it's diagonal. Every time you deal with a diagonal line, what form does it need to be in? Slope-intercept. All right, let's get them in slope-intercept. Let's subtract x. Y equals, the x goes first, it's a -x. That's a +5. Do you know the number for slope? Yep, it's the number being multiplied to x. It's -1. We write it as a fraction. The same thing over here. It's a diagonal line. We're going to subtract the 2x. We're going to get y equals -2x plus 5. What number's the slope? It's the number being multiplied. It's -2 over 1. Everybody look. Are these moving the same way? Do they have the same slope? No way. This line's moving down 1 to the right 1. This line's moving down 2 to the right 1. Well, if you think about that, they would eventually touch. If I move down 1 to the right 1, and this one's moving down 2 to the right 1, they're eventually going to collide. So these are not parallel. Are these going to be lines that are perpendicular? Well, to be perpendicular, the slopes have to be the opposite reciprocal. Are they opposite of each other? Nope. That's negative, that's negative. So that's not what it is. So we would say these two lines are neither. Now, what does neither mean? Neither means that when you go to draw a picture of these two lines, they would intersect, but it wouldn't be at 90 degrees. So if you drew a picture of these two lines, they would touch, but you would get either an obtuse angle bigger than 90, or you would get an acute angle less than 90. So what we talked about today only is this concept of slope. Slope is a key concept for lines. It's the movement from point to point. There are 3 ways to find the slope. Yes, you have to know all 3 ways. I'm visual. I like to use a picture. If I can't use the picture, I have a formula. Or I can use an equation. And then we discussed if lines are parallel or perpendicular, how their slopes are related. Okay, we have one more module in this section. Talk to you later.